Welcome to another video and welcome to this tutorial. In this tutorial we are going to be discussing function and mapping, and if you are just coming to this channel, please do it to subscribe and turn on the notification bell. And what is mapping? Mapping is a rule of assigning domain to its codomain. That is the rules of introducing domain to its codomain. As domain here is just like, for instance, if I call domain is son and the codomain the father. That is, when we are introducing son to its father, so we call it mapping. All right. So, and it's just like if I say the son is A and the father is B, I mean the domain is A and the codomain is B. So just try to put an arrow, then A will map to B. That is, A will go to his father, the son will go to his father. And Y for the function is a mapping itself whose codomain is a set of real number. All right, that is any value that we plug in, all right, as any domain that we plug in the particular functions, its codomain, which is the father, must be a real number. That is, in a mapping a function, we only deal with a real number, so not other numbers. That is, we are not dealing with complex number, we are dealing with real number, and the symbol for real number is this R. So just like we double the back, so that is the real number. A real number can be positive, negative, zero, fraction, and others like that. So while the function can come in such a way that if you have f of x, can also be f colon x, and while g of x can also be g colon x. So anyhow you write it, either I have f bracket x or f such x or f column x, so they are still the same thing. All right, and let's see the example of mapping. So because we said it's a rule of assigning domain to its codomain, so we have 1 map to 4, 3 map to 8, 2 map to 6. All this one they are mapping. So 1 is just mapping to 4, so 2 is mapping to 6, so 3 map to 8. And why all this side, which is 1 to 3, they are domain, why this other side, which is 4, 6, and 3, they are codomain. Okay, so if this is clear, and let's see the second example. We have D map to A, that is D is the domain and while E is the codomain. So if I map 8 to 3, 3 to 8, I map 2 to 4, and I map 1 to 5. So this is another example of mapping. And while for this one, here is 1, 3, and 4, 6, and 8. So if I map 1 to 4, so I think you should be able to know where arrow is going. So the arrow starts from 1 and it goes to other side. But we can check this, 1 map to 4 and 6. So which means this is not a mapping, because it's just like we are introducing one son to two father. So is that even possible? No, that is not possible. So one son can only get one father, but father can get as many as son. So the above is not a sample of mapping. While for the function, so we are going to define a function based on a particular formula. Suppose I have this as x squared, that is, we are giving of 1 to 3 as the value of domain. So we want to know the output of this codomain, all right? And to know that, we are going to be applying the formula above. That's why we call this one function. The codomain will be a member of real number. So, and another name for codomain is also range. So suppose we have x to be equals to 1, if you put the value of x, which is 1, we are going to have 1 square. Since we are following the formula, which is x square, we have 1. So while 1 now map to 1. And if you have at x equals to 2, which is the domain, we have 2 squared, that is 4. That is 2 mapped to 4. Or y for the last one, 3 raised to the power of 2. Remember that we are following x squared. We are following the given function. So that is 9. And all this one map to this, 2 map to this, 3 map to this. We get the function based on the given problem. All right, give us the given formula, which is x squared. So while for the next one, we have g of x equals to map to y, as we are following x plus y as the given function. When x equals to 3, we have 4. When x equals to 2, we have 3. When x equals to 1, we have 2. So that is following the formula, which is x plus 1. So that 3 plus 1 is 4, 2 plus 1 is 3, and 1 plus 1 is 2. That is what in by the word function. While let's see the last one here. So the last one, I'm going to do something different. So I want you to know that for every range, which is the codomain, their number must be unique. I mean, we are going to have a unique number. That if number repeats, so we just take 1. Okay, suppose I have 1 and 4 here, and here I have let's say 1, 2, and 3. So if 1 map to 1, and we have 2 also map to 1. Okay, and y we have 3 map to 1. So what this one is trying to tell us is that if you try to derive that formula and we try to plug in 1, we are going to get 1 as the value of codomain. And we still try to plug in 2, we're still going to get 1 as the value of codomain, which is the father. So which means that this father is having 2 sons, and which this is totally a function. And why we have 3 which map to 4. So here is a function because one father is taking 2 sons. Okay, so let's see another. What are the terms used in a mapping? So we have image of a function. F is a set of those elements, right? B in P such that A comma B is a member of F for some A in B. That is what this one is trying to tell us, that the output of a value plugged in a function is known as the image, and it is denoted by im of f, that is image of f. So what I'm trying to explain here is, for every mapping, let's say for every function, we are going to have the image. So that is, if you try to plug in the domain, there must be an input, there must be an output. So that output is known as the image. Suppose you have f of x equals to 3 minus x, and where x equals to 1, 2, 3. Okay, so now if you try to plug in 1 here in this formula, we are going to have 3 minus 1, which is equal to 2. This 2 is the output of the 1 that we plug in using 3 minus x as the formula. So and y2 is now the image, that is the output of that what we plug in, which is 1. Okay, we plug in 1 and we get 2. 2 is now the image of 1. So y pre-image is the input values of a function. So as from the example above, we have 1. This 1 is the input, which give out 3. So this 1 is the pre-image. Okay, we have 1 as the pre-image. Y2 is the real image, that is input and output. So input is the pre-image, output is the image. And let's see this one more example. We have h of x mapped to y. So let's say here is a function, so which give an output which is the codomain. Y is the codomain and y h of x. So the x we are going to plug in will be our domain. So we have h of 1 is 1, h of 2 is 1, h of 3 is 4. So now what is the domain and the range of the given functions? Alright, and suppose we have h map to y, so then we have h of 1 which is equals to 1 as it has been given in the formula, and we have h of 2 equals to 1, h of 3 equals to 4. The question says determine the domain and the range, this particular formula. And to know that, so you know that domain and range is what I asked to find. This domain, how is the range? I know range is also known as codomain. And to obtain the range and domain in this formula is very, very simple. So all these inputs, that is what we plug in the function, I mean the 1, 2, and 3, all these one they are known as pre-image. Okay, and as far as they are pre-image, and 1, 1, 4, they are known as range, and that range is also known as the image. Okay, which is also known as codomain. So which means all the pre-image they are known as domain. Okay, which is the son, while the range, which is 1, 2, they are known as 1, 1, 4, they are known as range. Okay, so now, but if you want to know this, you know I said earlier that the range they are always unique. I mean the codomain they are always unique. So you know we have 1, 1, 4, but I ended up having 1 and 4. So 1 and 4 is the solution, but if you take 1, 1, 4, this is not true because we are taking the unique value, and this one is following the cardinality of a set. You know the total number of elements in a set, but when number repeats, we count it as 1. So just for you to know that the range is always unique. If it repeats, we count it as 1. And let's see the next thing in this chapter. So let's see the serial of a function. So the serial of a function is just like we are going to begin a function and we give the domain. So we are going to plug in that function to get the range. That's what I mean by the word zeros of a function. So we are giving this function f of x equals to x squared plus 2x minus 1, and we want to find f of 3, f of minus 1, f of 0, and others f of that we have. So the real question is f of x equals to x squared plus 2x minus 3. Why a says find f of 3. So that is, if x equals to 3, we are going to replace all where we have x by 3 in the formula. Okay, and so to do that, we have f of 3. So we have x squared, that is 3 squared, plus 2 bracket, we have 3 minus 3. And 3 square is 3 times 3, that is 9, plus 2 times 3 is 6 minus 3. And everything here becomes 12. That is, f of 3 in that function is 12. As 3 now is the domain, while 12 is the codomain, which is the range or the image. So we can do all these, but let's see f of 1 over 2. So we have f of 1 over 2 equals to 1 over 2 all raised to the power of 2 plus 2 bracket 1 over 2 minus 3. So 1 over 2 square is just like we have 1 square divided by 2 square. That is product power of indices plus, so 2 we multiply by 1 divided by 2 minus 3. And 1 square is 1 divided by 2 square is 2 times 2, that is 4. Plus, if 2 cancel 2, we are going to have 1 minus 3, and this is equivalent to, suppose I have the first one is 1 over 4, plus 1 minus 3, that is minus 2. And if this 2 is taken over 1, and we are going to find the LCM in this, the LCM here is 4, because it's the biggest number and is the highest number that 1 can go, and 4 can also go in it. So and here we have 1 minus 8. We are multiplying 4 by 2, so and 1 by 1. So here the result is minus 7 over 4, which is f of 1 divided by 2 using the formula above. And we got minus 7 divided by 4. So minus 7 over 4 is our codomain, and 1 over 2 is our domain. So you can try this, so just like we get f of 3, f of 0, and you try to plug in all the value, then you subtract, so followed by the next one. And that is how we are going to stop for this. So and we are going to continue from this as the part 2 of the mapping and function. Thanks for watching.